I want to do a little more practice with you on distribution. There's some examples that I really didn't cover in the rest of the flip book, and I just want to make sure you're aware of how to deal with them. Interesting situations, you won't see them very much in this class, but what if we have 6x squared, there's our monomial, and here is our binomial? Well, same rules of distribution apply. The 6x squared goes to the x, and the 6x squared goes to the positive 2. I'm going to go ahead and write this out long, all the way out, so you can see what this equation is going to look like. So it's going to be 6x squared times x plus 6x squared times 2. All right, how do we combine these? Well, the 6 does not have another number to combine with it. Technically it does. There's a 1 here, but 6 times 1 just gives us 6. And x squared times x to the first power, that's 2 x's, and we're multiplying it times a third x, so that's 3 x's that we're multiplying. That becomes x cubed. And this last one, now the 6 can be multiplied by the 2. 6 times 2 is 12. The variable x squared has nothing to multiply with it, and so it ends up being 6x squared. There's our final distributed expression. All right, let's take a look at this one. Negative 3t cubed v times t squared plus v. Well, same rules apply. It might look a little messy, but everything works the same. Multiply it times the first term in the binomial and times the second term in the binomial. We have negative 3 times t cubed v times t squared, and we have negative 3 t cubed v times v. Let's go ahead and combine those together. The negative 3 has nothing to combine with it. T cubed and t squared, that's 3 t's times 2 more t's. That means we have 5 t's. And the v has nothing to go with it. Minus, okay, the 3 also has nothing to combine with it. T cubed has nothing to combine with it. V times v is v squared. So hopefully you're getting the hang of this. Doesn't matter how crazy our exponents are, you just follow the same rules of distribution. We got 2.5 minutes to get these last couple done. All right, what if we're distributing a monomial to a trinomial? Good news is, same procedure. 3 goes to the first term, the second term, and the third term. 5 goes to the first term, second term, and the third term. So we've got 3g squared minus 6g, that's 3 times negative 2g. 3 times 4 is positive 12. Now we're going to distribute the positive 5 to the 2g squared. 5 times 2 is 10. Oops, and I wrote 5. 5 times 2 is 10g squared. 5 times 4 is 20g. And 5 times negative 7 is negative 35. Let's mark our like terms. We've got a 3g squared and a 10g squared. We've got a negative 6g and a positive 20g. And we have a positive 12 and a negative 35. We'll go ahead and rewrite this and combine those. 3g squared plus 10g squared is 13g squared. Negative 6g plus 20g is positive 14g. Remember, negative 6 plus 20 is positive 14. And plus 12 minus 35 is negative 23. So there is our final distributed polynomial. And this final example of distribution practice can be very tricky for many students, and I see mistakes happening all the time on these types of problems. And where the problem comes in is all these negatives. these negatives end up creating issues for students as they work their way through distributing. So I'm going to go through with you how I would solve this problem, and hopefully as I talk you through it, hopefully it will make sense to you. Well, this first part is not so difficult. Monomial times a binomial. We know that process. Distribute the 2 to the first term and the 2 to the second term. And we're going to end up with 2 times 2g squared is 4g squared. And 2 times negative 4 is negative 8. Alright, now here's where the difficulty comes in. A couple things we're dealing with here. One, we got a negative sign or a minus sign. Number two, now we're multiplying 3 different values. You've got a monomial and a binomial and a binomial. And the question is, how do we combine these all together? One thing I'm going to tell you is, don't try to do it all in one step. It's possible, but very difficult. We're going to break this down into 2 steps. We're going to pick 2 of these, either the 2 binomials or a monomial and a binomial, 2 of them. We're going to combine them together, and then we're going to go ahead and combine the third part. And think of it like this. If you're making a cake, and let's say you're using milk and eggs and flour, you can combine those all sorts of ways. You can put the milk and the eggs together in a bowl and whisk them all together and then add the flour. You can put the milk and the flour together first and then add the eggs. But you're typically not throwing all 3 of them in at one time. You're doing 2 of them first, and you're combining them, and then you're putting the third one in. And so in this case, think about it. We're going to put 2 of these together first, and then we're going to put the third one in. Now, the tricky part is, let's look at this minus sign right here. Okay, I'm going to show you how I'm going to handle this. I'm going to put that in our equation right here. That minus sign cannot disappear. It's going to be here. But after I write that minus sign, from here on in, I'm going to ignore it. I'm going to do all of my combining just assuming that minus sign is not there. Now don't worry, I'm not erasing it. I've already written it down. I've already taken it into account. So now I don't have to worry about it from this point forward. I'll deal with it a little bit later on in our problem. So let's take a look. I've got a monomial times a binomial. Let's do that first. We'll do 3 times g and 3 times 5. Now, that's going to end up staying in parentheses, because we're going to have to take the answer that we get here and multiply the whole answer times the g minus 6. Watch what I'm going to do. I'm going to put g minus 6 down here because that's our third ingredient. We're not going to touch that yet. We're going to leave it alone. We'll combine that in later on. Let's go ahead and combine our monomial and binomial. 3 times g is 3g, and 3 times 5 is positive 15. Now notice, students, I ignored the minus sign. I already put it here. I don't have to deal with it when I'm doing my combination or my distribution. So this is positive 3 times positive 15. All right, so far so good. We got one more step now. Let's go ahead and write this as 4g squared minus 8. Remember, we're going to still have this minus sign floating out here. And now I'm going to go ahead and put 2 parentheses here. And I'll change this to a different color so you guys can see this. Here's my 2 parentheses. I'm going to go ahead and combine these 2 binomials together. Now I'm going to use the FOIL method now because it just makes it a little bit easier. You can use the other method, and I'm having a hard time remembering what it is the grouping method. You could use that method, but I'm going to use FOIL right now to show you that other option that we talked about. So FOIL is going to be first terms, outside terms, inside terms, and last terms. Our first terms are 3g and g. 3g times g is 3g squared. What are our outside terms? They are 3g and negative 6. 3 times negative 6 is negative 18. Tell the variable g there. Okay, inside terms. Inside terms are 15 and g. Those are both the inside values of our two binomials. 15 times g is positive 15g. And now we have our last terms. 15 times negative 6. 15 times negative 6 is negative 90. Let me check my answer there. Yeah, negative 90. All right. So we have done our second step. Third step, let's take a look. Remember PEMDAS, we're going to deal with parentheses first, and I can see on this equation, in parentheses, we can combine two of these terms. We got negative 18g, got positive 15g. So let's write this down. We got 4g squared minus 8. Here is our minus sign that's still hanging around. And we've got our parentheses. We've got 3. Oh, let's write that back in red. We've got 3g squared. Negative 18 plus 15 is negative 3g minus 90. All right. So far, so good. Now we're done with our parentheses. We can't combine any other terms inside the parentheses because they all have a different variable with a different exponent. So now we're going to deal with this negative sign here. Let's go ahead and do this next step. We've got 4g squared minus 8. And now we have to distribute this minus sign. Remember, class, even though there's no number in front of the parentheses, we can just assume that is the value of 1. This is actually a negative 1. I'm going to write that so you see this. We have to distribute the negative 1 to all of the terms inside of our parentheses. All negative 1 does is flip the sign. So negative 1 times 3g squared is minus 3g squared. Negative 1 times negative 3g, remember, a negative times a negative is a positive. That's positive 3g. And negative 1 times negative 90 is positive 90. Almost done. Last step, can we combine any like terms? And we definitely can. We've got a g squared here and a g squared here. We have no other g terms, so there's nothing to combine there. But we do have a negative 8 and a positive 90. Let's go ahead and do our final combining and then we'll be done. 4g squared minus 3g squared. 4 minus 3 is 1. So we just end up with 1g squared. I'm just going to write g squared. It's the same thing as 1g squared. 3g couldn't be combined with anything, and so I'll just write that as positive 3g. And negative 8 plus 90 is positive 82. So there is our final. Let me see if I can put a circle around that without erasing anything so you can see it. There is our final distributed polynomial. G squared plus 3g plus 82. Lots of steps, class. Again, the most important thing is I want to teach you here is how to handle this negative sign so you don't end up messing up the signs in this second part of our original expression.